The only thing I hate more than standing is waiting for my desk to stand and getting it to the right height each time. So that's why I built my own custom standing desk controller to make my standing desk smart and automated. I bought this basic standing desk about 5 years ago and opted to get the manual standing desk to save money, but I've regretted it ever since. So I started out by reverse engineering the standing desk controller. I opened it up and found out it's just two simple switches that reverse the polarity to the motor depending on the button pressed. And I noticed that the two switches are just switching between normally open and normally closed terminals, which is very similar to a relay. So I figured I could just replace the switches with two relays and control them via an Arduino. Next, I need to figure out how to get the standing desk to the right height each time. I first looked at adding limit switches to stop the desk at the right height, but that seemed unreliable and not the easiest thing to get right. Then I noticed there's a shaft that goes between each leg of the desk and rotates to keep each leg of the desk at the same height. If I can track the rotation and convert it into a height, I should be able to control the desk. I decided that a basic rotary encoder, normally used for volume knobs and menu selection dials, might just do the trick. And if I can attach it to the shaft with some 3D printed gears, it might just do the trick. I connected the encoder and the relays to an Arduino and wrote some basic code to test it out. It worked surprisingly well, and I could even control the desk within a few millimeters of accuracy. However, the gears are really noisy, and I'm hoping that if I can make a few minor changes and print them in nylon, they'll be much quieter. And that's where today's sponsor comes in, JLC 3DP. JLC 3DP provide high-end 3D printing services with a wide range of materials to choose from, including stainless steel and full-color resin. Ordering the parts is really simple. Just upload your files, choose your desired material, and submit them for a quick design review. If everything looks good, they start production immediately after payment. After browsing through their material selection, I immediately had the idea to get the gears printed in nylon, hoping they'll make the gears quieter and more durable. I also added the circuit boards for this project to the same order, and they all arrived at the same time, which made assembly really easy. I was really impressed with how good they turned out, and the packaging was really solid too. After installing the new gears, they were significantly quieter, and I no longer hear them when raising or lowering the desk. So if you're interested in their services, check out the link in the description. I did run into one minor issue with the nylon gears. They were too smooth and kept slipping on the shaft compared to my press-fit PLA gears. But the advantage of SLS printing is they have 100% infill, so I could easily drill a hole in each gear and add an M3 screw as a lock nut on the shaft so they don't slip anymore. The next step is designing an enclosure to hold all the electronics. I want to have 5 buttons, manual controls for up and down, and then 3 custom set points for different heights. I wanted to try something I've never done before, and that's print and place buttons, similar to how Prusa do their buttons on their enclosures. Using these tiny micro switches I already had, I mounted them inside the enclosure and made a circular cutout for each button with a tab to hold it. It took a few tries to get the spacing right, but eventually I came up with a button shape that works. Once I had a button design I liked, I modelled a case to fit all the buttons and a prototype PCB. I wanted to have coloured labels on the buttons, so I needed to design it with the buttons face down. This meant there was a bit of an overhang when printing, but surprisingly it printed with no problem without any supports. And as a bonus, it made the enclosure stronger due to the diagonal layer lines. The code for the desk is fairly simple. It uses a simple rotary encoder library to quickly calculate the height of the desk, and when the button is pressed, it sets a target height to achieve. It will then turn on the relays and raise or lower the desk to the desired height. If the Arduino gets a bad reading from the rotary encoder, or it disconnects or stops, it also stops the desk as a safety feature. The desk needs to know exactly how high it is when the Arduino first powers up, so it first does a calibration routine. It lowers itself to the lowest point of the desk, and when it stops, it sets the home position. This is triggered when you press button 1 and it saves the position in the Arduino's EEPROM and will automatically home when it reaches the bottom. As I have 2 of these standing desks, after making a few prototype circuit boards and getting the code working, it's time to create a custom PCB. It's relatively simple as well. It has a step-down voltage regulator to convert the 30 volts of the desk to 5 volts of the Arduino, and 2 relays to control the desk. It also has connectors for the desk, the buttons, and the encoder. The connectors are the same as the original manual controller, so if I need to go back to the manual controls, I can do that at any time. I end up having to get the board made again as I made a few mistakes in the first one. So now the fun part begins, building the circuit boards and assembling the controller. There's one more little party trick I added to this controller. Because the Arduino Nano has native USB serial, I decided I could plug it into my computer and write a quick app to control the desk from my computer. I don't know why you'd need this, but it's a bit of extra fun and it's useful when I'm being super lazy. I don't even have to take my hand off my mouse. The desk ended up being really precisely controlled within a few millimeters and much better than I was expecting. I'm really happy with how it turned out and I'm definitely going to be using my standing desk more now. As usual, all the code and 3D files will be available in the video description. If you enjoyed this video and would like to see more projects like this, don't forget to like and subscribe. See you in the next one.